Hi, Pods from wish.com here. This is a power supply. This is a power supply. Oh shit. And this is a power supply. Now, what do all of these have in common? I'm glad you asked. They're all dead. Well, other than that, all of these power supplies have a fan. Now, what will happen if we run a power supply without its fan? Well, it would sense that it is getting overheated and it would just shut off like it really should. But here we have a power supply that decided not to do that. So let's see what happened. This right here is what will happen if you run a cheap power supply without its fan. So first the board is warped. This inductor is very burnt, and the circuit board around the fan, around the inductor, is very charred. The underside is also very charred, and also it got so hot that the capacitors literally desoldered themselves. The power supply was likely used upside down, so the capacitors literally just fell out. Here you can see. The board is cooked. Now the funny thing about this is, yes, the lacquer on the wire is missing, but I bet the power supply died really because the capacitors fell out. If I were to replace these capacitors, I think it might work again. You know what? Let's plug it in and see what it does. Okay, so here in this setup, you stay there. This is a tester. On the input I connected live and neutral. Live to the input of the fuse and neutral to the output of the passive power factor correction inductor, and it's all powered by this little inverter. Its power is only limited to around 30 watts, so nothing should explode, I hope. 12 volts and ground. And oddly enough, the standby power supply still works. It actually tries to turn on. I wonder if I fix the output capacitors, would it actually turn on? Let's go ahead and give it a shot. I mean, none of the outputs are shorted. Okay, now I resoldered the connections because I noticed some of them are very broken, and let's see if it turns on. Oh, it doesn't. I see the minus 12 volts is the only LED that doesn't turn on. Okay, let's see what's going on there. Oh shit. Minus 12 volts is this one, and it goes here. And the other side goes where? That's soldered properly. This one, I think that's these should be good. Yeah, they're good. Maybe one of these diodes is... No, it's good. This one? No, it's not shorted. Well, I see nothing else, so let's give it new capacitors. Alright, here on this very exploded board we have a 4000 microfarad 35 volts. That should be good. Good enough. Here we have 4 capacitors. Now I won't be replacing them, I'll just put these in series and hope for the best. $12 volts. Let's see if it turns on. Um, it's cycling. I can't say for sure that I know what that means in this case. Let's try to figure it out. Oh shit. Nice. That's fun. Nice burn mark on my screwdriver. Oh. It's the minus 12 volt rail. Or not? It is. It's not connected properly. Let's fix that real quick. Oh. So, you see what really happened. I'll remove this capacitor. What really happened is, I don't know if you can see it, but right here is a cracked trace. So if I jump it, like this, now, nice. Now I put the capacitor back on. Oh, that's odd. So it starts and stops. That could be because there is no load. Let's fix that real quick. Oh, that was fast. Where it's broken fan. This is the power supply. Here is the fan connector. Put this aside. Right here. Let's try to start it now. Oh. Oh. Oddly enough, the fan is now trying to turn after I freed it up. Oh, it's dead. It's still cycling though. This diode shouldn't be blinking, it's -5 volt, and this power supply doesn't have a... Yeah, it doesn't have a -5 volt rail. Why would it be blinking? Maybe it needs more load. It seems to me that it doesn't have enough power to run, which is weird. With the meter on the 1000 volts. Yeah, it's drawing a lot of power. It should be dropping to 140 volts. Oh, I smell it. Oh, I'm an idiot. Oh, I'm an idiot. The capacitor. This capacitor right here is... This is negative voltage. So the positive... Oh, oh. Wow. Focus, please. It's really hot and you can see the bulge. So, yeah, I cooked this shit. I cooked this capacitors. I cooked this capacitor. Let's see if it will work anyways. So the positive goes to the ground and the negative goes to the negative 12 volt rail. So upside down. Let's see if it works now. There it is. See, even the fan is... It's trying desperately to spin. That's kinda neat. You know what? Let's try to remove the capacitors and see if it still works. So I leave all the original capacitor. Oh shit, I forgot to discharge it. Yeah, didn't zap me though. Who cares? Alright. See, all of the capacitors are back in place, and I remove the fan. The only load still attached is the LED strip. It's still connected. Inverter on. Oh, that's it. Okay, it doesn't lock. It doesn't like that. So, is any of the capacitors shorted? I don't think so. Nope. No. 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 Okay. I guess these are, I think, all regulated on the 5-volt rail. So if I return the 5-volt rail capacitors, I think it should work. So this capacitor only. No. No. That's interesting. Shite. Maybe what is this? 3.3 volt rail. I put it upside down. Oh, it's still recording. It is. Oh, I think I just blew a fuse on my power supply. Who cares? No. Interesting. Interesting. Let's try the 12-volt rail then. I'd be kind of surprised if the regulation is done on the 12-volt rail, because it's typically, though this isn't an old power supply, it could be on the 12-volt rail. It's usually always on the 5-volt rail on the older. There it is. I mean, the power OK signal isn't online, which is strange. I mean, isn't strange, but let's see. Oh. Let's see what are the voltages. So 20. 5-volt rail is at 5.2, that's fine. 12-volt is at 12.1. Negative 12 is at negative 10. That's fine. 3.3. I mean, all the voltages are kind of there. So the regulation is done on the 12-volt rail. That's interesting. Let's see which rail is causing the power OK signal not to turn on. Oh, I fucked it up again. Okay, this is negative 12 volts. Power OK is still not there. Like this. Like this. Oh no, that's not. Something smells again. Did I connect one? Yeah, something smells bad again. Who cares? If it blows up, that's content. Still nothing. Content. Now. And oddly enough, we still don't have the standby, the power OK signal, which is weird. We have all the voltages, but we don't have the... Okay, let's check voltages again. Ground, negative 12 volts, negative 11.4. That's fine. This is 12 volts, this is 5 volts, and this is 3.3. So they are all correct. Maybe it just doesn't have the load it wants. Let's see, maybe it just wants the fan connected. It may want more load. What happened? It's still... The power OK signal is still down. Why? Excuse me, what the frick? Why? Why? I can't connect any more load because the inverter will trip. Maybe this capacitor is just bad. Oh, let's find another. No. 16 volts, that's good. Where is it? It's right here. Okay, get the fork out of here. And you connect there. Nice. Actually, let me see what this capacitor... I did kind of burn it, but it shouldn't be that off. Oh, it's still good. Huh. ESR 0.00. 470, 440 micro. That's interesting. So this capacitor is good. Anyway, let's see. The fan is kind of coming back to life. Oh. It's trying. Trying its best. I'm not quite sure why the power OK signal is dead. Is it getting enough voltage? 200. Okay, so the voltage might be a bit low. 220, it should be 330. Actually, let me test the tester. Where is my delta power supply? Okay. This is a good brick. It's a delta from an HP. This is a delta from an HP power supply. If I plug it in and take the tester, give it. Yeah, it has a power OK signal. The white LED is negative 5 volts. This is an older power supply, so it has the rail. But the tester works. That's odd. Is there anything else that could be cooked? Like if any of the rails wasn't working, or something was shorted, or any sensing rails didn't work properly, the power supply would trip, I would assume. Well, I wanted to try to turn on the actual computer with this, but the power OK signal is still not turning on, so the motherboard wouldn't turn on. I guess that's it. That's it. It kind of works. You could use this as a bench power supply, I assume. Oh, it can still deliver quite a bit of current, which is interesting. But yeah, I can't use it to turn on a motherboard, which is, oh. That's kind of sad, but I guess that's it. See ya.